Hey guys, this is a video in my Differential Equations with Linear Algebra series. In this video, I'm going to work through a Webwork problem pertaining to Newton's law of cooling. Without further ado, let's get to it. The question states, the thermometer is taken from a room where the temperature is 19 degrees Celsius to the outdoors where the temperature is -4 degrees Celsius. After 1 minute, the thermometer reads 11 degrees Celsius. The first question we have to answer is, what will the reading on the thermometer be after 3 more minutes? We're dealing with the temperature and something warmer is cooling to ambient temperature. So right away we know that we need to do something with Newton's law of cooling. And another thing to notice is the word more. So 3 more minutes. 3 more minutes would make the time equal to 4 minutes after it's been taken to the outdoors. So we'll start with the expression for Newton's law of cooling, where we have d capital T for temperature over dt, which is time, equals k times A minus T. Big T is temperature, and that's a variable. A represents ambient temperature, which is the outside temperature or the surrounding temperature, and that's a fixed number. Little t is time, and that's the independent variable, and k is a constant. Big T is a function of little t, so temperature changes with time, and that makes sense, right? If you're putting something warmer in a cooler environment, it's going to cool to that temperature eventually. Next, we'll notice that this is a separable differential equation. So we'll go ahead and do that. So we're going to multiply both sides by dt and divide by A minus T. That will put this t and this t on the same side, this dt on the same side, and k is just a constant, so that will work out really nicely. So d capital T over A minus T is equal to k dt. Next, what we're going to do is multiply both sides by negative. I'm going to do that because I have minus t, and I don't really want the negative t. You can do it this way, it will still work out, but I'm just going to multiply both sides by negative. So I'll have d capital T over t minus a equals negative k dt. I just did this because it's much easier to have the negative on this side than have a negative t. Next, this is just an easy integration. We can integrate both sides now. This just becomes natural log of t minus a. Since we took the negative out, we don't have to worry about a negative sign on the outside. And then we just have negative k, and since we're integrating with respect to t, dt, so kt, and then plus an arbitrary constant, so plus c. We have t, or the variable temperature, inside the natural log, but we don't really want that, so we're going to raise everything to, we're going to have e raised to everything over here. The natural log and the e cancel each other, so we get t minus a equals e to the negative kt plus c. And a property of exponents is if we have x raised to an a power and we have that multiplied by the same base raised to another power, we can rewrite that as x to the a plus b. In this case, if we go in reverse, we can say we have t minus a equal to e to the c times e to the negative kt. And this whole thing is a constant, so I'll just call that c. So I'll rewrite it one more time, where we have t minus a is equal to c e to the negative kt. So this is the expression we just came up with, and these are the givens. This is what we don't know, and that's what we're actually looking for question A. We know that the ambient temperature, or the outside temperature, is -4 degrees Celsius. When time equals 0, that's the instant that the thermometer is just taken from the room to the outside. And at that instant, the reading would still be what the reading was inside the room. So that's 19 degrees Celsius. And we are given that when time equals 1, the reading is 11 degrees Celsius. So we're going to use this information to figure out the things that we don't know, which is C and K. And finally, we're going to try and figure out what T of 4 is, which is the temperature reading when time equals 4 minutes. So we're going to go ahead and substitute the values that we already know. So T minus ambient temperature, which is -4, is equal to C e to the negative KT. When time equals 0, the temperature reading is 19 degrees Celsius. So we're going to use that information and figure out the value of C. So we have 19 minus negative, that's just plus 4, is equal to C e to the negative K, and time equals 0. And anything raised to 0 power is just 1. So C is equal to 23. Next, we're going to use the fact that we know T of 1 is 11 degrees. So 11 plus 4 is equal to 23 e to the negative K, and time is 1, so 1. So we're going to isolate for e to the negative K, so divide both sides by 23. So we get e to the negative K is equal to natural log of 15 over 23. And we'll take the natural log of this side also. The reason I took the natural log is we would have e to the negative K equals 15 over 23. And to get rid of this a, we need to take a natural log of both sides. So we'll have K equals whatever this value comes out to, and then K comes out to 0.427, and that's positive. This is the natural log of a number that's less than 1, so that will be negative, and the negative will cancel with this negative, so K will be a positive value. Now we're going to rewrite our expression with the values that we know. T plus 4 is equal to 23 e to the negative KT. And K, I forgot to substitute in, is 0.427. So I'll rewrite that again. T plus 4 is equal to 23 e to the negative 0.427 T. Now we're looking for the temperature when time equals 4 minutes. So we're just going to substitute in little t equals 4 and figure out what the temperature is. So big T equals, we'll just subtract 4 from both sides, so T is by itself. So -4 plus 23 e to the negative 0.427 times 4, and temperature comes out to about 0.16084 degrees Celsius, and you can round that however you want, but that's the answer for question A. Question B is the last question for this problem, and it asks us, when will the thermometer read -3 degrees Celsius? Blank minutes after it was taken to the outdoors. This problem should be really easy since we already found the expression for temperature in part A. We're just looking for little t, and we know big T this time. So let's go ahead and do that. This time we know the value of big T, the temperature. We just don't know what this little t, the time, is. So we know big T is negative 3 degrees Celsius. So negative 3 plus 4 is equal to 23 e to the negative 0.427 t. We want to isolate for this t, so we're going to divide both sides by 23, and we'll get e to the negative 0.427 t equals 1 over 23. And since we have e raised to the negative 0.427 t, to get t by itself, we need to take the natural log of both sides. And when we take the natural log of this, the e and the natural log will cancel, so we'll have negative 0.427 t is equal to natural log of 1 divided by 23. So we're going to divide both sides by negative 0.427 to get t by itself, and t comes out to about 7.34 minutes. And that's the final answer for part B. I hope this video is helpful. As always, if you have any questions, feel free to leave them in the comments section below. If you haven't already, please subscribe. Check out other videos on my channel, especially the Differential Equations with Linear Algebra series. Also check out the Graphing and Scientific Calculator tutorial series. And until next time, take care guys.